I spent the last month diving into the research around intra-workout nutrition. Everything from a high molecular weight carbohydrate to BCAAs to creatine to answer the question, what actually works? If I take this giant needle and do a biopsy of my quad, is there some sort of drink concoction that I can ingest while I work out that over the next 3 to 4 months will add more cross-sectional area, more sarcomeres in parallel in the individual muscle fibers? Or did I just stab myself with a Chinese biopsy needle just for the hell of it? So let's start by diving into the science around everyone's favorite macronutrient, carbohydrates. To fully appreciate these and be able to game the system, you're going to need a better understanding of exactly what happens between the time of ingesting this and it turning into muscle glycogen. So I'm going to run through this diagram real quick because not knowing this is how most mistakes are made. When you first put carbohydrates into your big fat face, they immediately start getting broken down both physically by the act of chewing and by salivary enzymes. Next up, the stomach. Why does that sound familiar? I spent my entire life working to turn into Mrs. Frizzle. Magic scuba's. Not much digestion happens here other than physical because your stomach is so acidic that it actually inactivates those salivary enzymes. Magic scuba's. Next up, the small intestines, where the majority of digestion takes place, where the pancreas dumps enzymes, the primary one for carbohydrates being pancreatic amylase, as well as the brush border enzymes will fully break those carbohydrates into monosaccharides. From there, they're absorbed into the bloodstream through mucosal cells that line the small intestines, eventually making their way back to the liver where they're all be converted to the usable form of glucose. Cool story, bro, but where's this magic glycogen? The easiest way to think about glycogen is it's just a shitload of bonded glucose molecules. So if your body goes through the entire process of breaking down a complex carbohydrate into its simplest form of glucose, it then essentially has to create its own complex carbohydrate, glycogen. How are we not dead? Your liver and your brain, to a much, much smaller extent, creates its own glycogen. And this is important to know because muscle building is a luxury and your body has a hierarchical structure in terms of divvying up its resources. For example, your brain metabolizes 60% of the glucose in your blood. I don't know if I have a liver around here. Fetus, placenta, penis. Your liver maxes out at about 100 grams of glycogen storage, but there's also a baseline level that needs to be met to maintain proper functioning. That's why if you ever see anybody ingest fructose during their workout, they're actually doing it predominantly for their liver. But more on that later. On top of other things in your body that take priority, like your kidneys and red blood cells, but that's in a non-exercise environment. When you train, everything changes. When you train, proteins named GLUT4, which are normally inside the muscle cell, move to the cell membrane or the surface of the cell, allowing for an increased glucose uptake. And the harder you train, the greater degree of GLUT4 translocation. Or simply more of those little GLUT4 bastards get their permission slip signed and they're allowed to go into the field trip to the surface of the cell, which brings in more glucose to that muscle cell. Ever heard of the anabolic window? That's exactly what this is referring to. It's just horribly named. It should be called the glycogen window because it's the period of time after you train that you can synthesize glycogen at a greater rate. Why is that important? Because glycogen is your muscle's primary source of creating energy, ATP. So if you don't take advantage of that window, you're more than likely going to be training in a depleted state. For the first 4 hours following your training, your body can synthesize 10 millimoles per kilogram of wet weight per hour, and then it drops back anywhere from 4 to 6. And I understand that's garbledygook. A millimole is equal to 1/1000th of a mole, which is a standard unit of chemistry representing a specific number of particles, 6.022 times 10 to the 23rd. We're dealing with things on an incredibly small scale. Just know that a well-trained fed athlete has around 150 millimoles per kilogram. As you train, that depletes. Once you hit 75 millimoles per kilogram, muscle function is impaired. Think about it this way. If you have an incredibly hard leg day and deplete yourself to the point that you can barely walk, obviously muscle function is impaired. You're probably below that 75 millimoles per kilogram. Unless you take advantage of that window of increased glycogen synthesis, you're not going to replenish your glycogen stores by the following day. Now, for most people, timing is less critical than total carbohydrates consumed because glycogen depletes locally. So unless you're one of those weirdos that trains full body 5 times a week, you're probably going to be fine. But there are those days where you train arms and then shoulders the next, and your shoulder day is affected because your triceps have been depleted. So it just makes sense to take advantage of that window. Also, you're probably wondering, what the hell does this have to do with intra-workout nutrition? It's because of this one sentence, that sufficient carbohydrate ingestion during exercise helps maintain maintain liver glycogen stores and has been reported to spare glycogen in type 2 fast twitch muscle cells, or muscle fibers, if you want to say it like that. Same. Even at rest, each muscle cell has roughly 1 billion ATP molecules that will be replaced every 2 minutes. As you train, that goes up 1,000-fold. So yeah, we can't expect glycogen to magically be replenished by ingesting a few carbohydrates as we train. It's a lengthy process. We can give our body the substrate it needs to help mitigate degradation. We can limit it. This should really open your eyes to how important it is to have a steady dose of carbohydrates during and after your workout. And because I know there's going to be some chode watching this that lives in his mom's basement while he finishes his kinesiology degree and can't figure out why she has so many male friends, is going to say, I've looked at the studies and they all average anywhere from 24 to 40% of glycogen depletion when you train. That's not enough to impair muscle function. We need to look under the hood and explain how glycogen is actually stored. 75% is intermyofibrillar, stored near the mitochondria. Another 5 to 15% is subsarcolemmal, which is underneath the cell membrane. And the last 5 to 15% is intramyofibrillar. And this may be the most important, because intramyofibrillar glycogen is located directly within the muscle cells where the contractile proteins are, the myosin and actin. And when those levels run low, it's been shown to impair calcium release, which is essential for muscle contraction. And this is important to note that these don't deplete uniformly. So while you might have a 24% overall glycogen depletion, you might have screwed all your intramyofibrillar glycogen. So yes, that can impair muscle function. And those are not your mom's friends, she's blowing them. Now that you understand the why, we gotta go over the what, because there's a lot of different carbohydrate supplements out there. Everything from amylopectin, to homopolysaccharide, to fractionated amylopectin, to highly branched cyclic dextrin. Now, the formulators of these individual supplements all had their hearts in the right place due to their high molecular weight and low osmolarity, but in choosing a carbohydrate source, we should have one guiding principle, and that is that high glycemic carbs replenish glycogen faster and more maximally than low glycemic carbs. So we should be looking for the fastest thing possible. So in that case, nothing's gonna beat dextrose. It is the nutritional equivalent to the glucose in your blood. It is a goddamn mirror image of the molecular structure, just flipped. Now, some of these companies will say the benefit of our drink is it doesn't give you GI distress. And I will say that's a pretty good selling point, because there's nothing worse than trying to squat and simultaneously flex your butthole at the same time. You only have to mess up once to never be allowed in that gym again. But in reality, if you wanted to use dextrose, because it's probably going to be the best, better than all of those different supplements, but you're worried about GI issues, then just dilute it to less than a 6% solution. Meaning that for every 6 grams of dextrose, you need 100 grams of water. So let's say you wanted 50 grams then you're going to need 783 grams of water, or roughly around 27 ounces. In terms of how much we should take in, your body has a pretty clear limit. The small intestine can only absorb 1 gram of glucose per minute, or 60 grams per hour. But if we add in some fructose, we can add an additional 30 grams, so 90 grams total, because they have completely different transporters. And this is critical because fructose predominantly restores liver glycogen. So when those stores are low, your muscles can go f themselves. To make your life easier, let me show you exactly what I do. I make an inflated post-workout shake that contains the carbohydrates I'm gonna have during my workout and after, and I split it up. I have a third of it during the workout and 2/3 after. I get a full bottle of Pedialyte, which is 25 grams of dextrose, and I add in 3 tablespoons of honey, because honey is a natural mix of dextrose and fructose, about 40% fructose. So all in all, I get about 83 grams of carbohydrates, 54 from dextrose, another 19-ish from fructose, and the rest is sucrose, which I'm fine with because that mixture together has been shown to increase carbohydrate oxidation. And remember, this isn't gonna instantly replenish your glycogen stores, we're just trying to minimize how much you deplete them. So this is how much I would get in during my workout, and this is how much I take in after. And honey is delicious. The next obvious question is, should we add some sort of branched chain amino acid or whey protein? And I think this is a very important question to answer, because in the last video where I talked about the significance of hitting that leucine threshold, people jumped to the conclusion that if they just added a bunch of BCAAs to everything, poof, more muscle. Poof, you're an idiot. Leucine is just the initiator. Without all the other amino acids, the train stops. So if I'm speaking to that kid who's getting his kinesiology degree, leucine is just one of your mom's male friends. Without all the other amino acids, all the other guys, she's not gonna get that train she desperately, desperately wants. I don't even know if that makes sense, but that kid. Essentially what you've done is made it all the way to the point that the messenger RNA has read the DNA sequence and knows the exact formula it needs to make the protein, makes it to the ribosome in the cell, starts to transcribe, but doesn't have the amino acids to get the job done. And you've wasted your time. So when it comes to building muscle, it's always better to have a complete source of protein than it is to have some BCAAs or EAAs. Now again, for me, I like to make sure the first meal of the day, the last meal, and my post-workout shake have the highest amount of protein. So for me, that's 66 grams. I'll have 22 while I'm working out, 44 after. But again, I can't just add it to my carbohydrate drink because that changes the concentration. We want anywhere from a 6 to 8% solution. So we have to add more water to it and make it taste like shit. So again, the same math applies. For every 6 grams, we add 100 grams of water, which turns out to be 34 ounces, which makes it taste like shit. But you won't shit your pants, so it's a fair trade. Now, a lot of people will just drink chocolate milk, which, again, same idea. Protein with carbohydrates increases the glycogen synthesis rate. Not bad, but not optimal. Why not just make it the best quality ingredients possible? Because milk is for babies. Now, the last question you should be asking yourself, is there anything we can add to this that would be beneficial? And the obvious answer is creatine. In one study, they had participants on a high carbohydrate diet deplete their glycogen stores, and then one group got creatine, the other group got jack shit. The group that got creatine had a muscle glycogen resynthesis that was 82% higher than the placebo group in the first 24 hours. Obviously, after a few days, they both caught up to each other, but that's significant for those first 24 hours, so why not? Now, in that study, they had them supplement 5 grams of creatine every 2 hours following their workout, but I think it's safe to say that we can put 10 grams in there, and then considering it's our intra and post-workout, and then if you wanted to follow that protocol perfectly, it's on you to take the remaining 10 grams the rest of the day. I can't follow you home and make sure you take your creatine and your Flintstone vitamins. And there you have it, the perfect intra and post-workout shake. Fucking honey stuck. That's not bad. The honey saves it. With that being said, if you don't know how to correctly calculate your macros, you're never gonna build muscle or decrease your body fat. That's why I filmed a video just for the app that shows you exactly how I do it, because it's a little bit different and I think it's even more accurate. On top of the way I structure the individual macronutrients, I think it's gonna be incredibly helpful. Also, the Garage 2.0 will be added to it soon. I just wanted to add a shitload more exercises to make sure you can really hurt yourself. The link is below. Get after it.